Hi there, and welcome to another episode of Mr. Carlson's Lab, and possibly the beginning of another small video series. Now, I'm thinking of calling this small video series a sneak peek or a sneak preview at future projects series. So basically, it's going to be like looking at this thing, a sneak peek at what's going to be on this bench in the future, and then it'll be like a mini teardown video. So we'll take a look inside and I'll explain what's inside and how the circuitry works. And then down the road, I'll end up doing an entire restoration on this device, and that'll be a separate video again. Now, the reason that I'm thinking of doing this small series is just because my normal videos just take such a long time to do, and it's usually 3 weeks or longer between the videos that I can get up to YouTube. So this might allow me to get an intermediate video, if you want to call that, get that up to YouTube in the meanwhile. So every week and a half or 2 weeks, I may have a video up. Now, I have lots of people asking me, Paul, is it possible for you to do an intermediate or a Tech Tips Tuesday kind of video? And the reason that I did stop doing that there for quite a while is just because when I did those Tech Tips Tuesday videos, they are kind of in-depth themselves. But whatever's on the bench at that time, I have to take that off, do the Tech Tips Tuesday episode, and then get that produced and up to YouTube, and then put the remaining project back on the bench. So the restoration kind of, has to come on and off the bench. And it'll be kind of the same way with this, but at least with this particular kind of video, this kind of gives you a sneak preview at what we're going to be doing, and I can get your opinions on what you think of this and if you'd like to see the entire restoration or not. So it's kind of beneficial in a bunch of ways. Video content up for you guys, and we can kind of have that interaction thing going on to where, if you'd like to see if there's enough positive response on a restoration video of this, or if you don't want to see it at all, kind of allow me to gauge what you guys are interested in. So for myself, I find this thing extremely impressive. The thing is massive. It's a double signal generator with a vertical oscilloscope mounted in the center here, and you view the oscilloscope through a mirror. If I put my hand on the top here, you can see that I can barely reach the other side of the piece of test gear here. This is designed for FM and TV. And when I end up restoring this thing, I have a bunch of old televisions that I'm going to show you guys as well, and we'll do some restorations on some TVs. So after this thing is restored, I'll include this in that older test bench that I'm going to be setting up, and we'll use this for television alignment and things like that. So this was donated by a friend to do this video on, and so that I could share this with you guys. So it was very nice of that friend to do that for me. And my friend likes to remain anonymous, so we'll just keep it at that. So let me know what you think of the series, and let me know what you think of exactly what I'm doing here in the comments below. Don't feel shy. I read every single comment that's posted. It's impossible for me to respond to every single comment, but I assure you I do read every single comment, and I take them quite seriously. So leave your thoughts and your ideas below on this series, and this series won't just have old equipment like this. There'll be some new modern stuff in here as well. So whatever I find that's going to be on the bench in the future, something for a future restoration, and maybe even some future circuit designs and things like that. So what I'm going to do is reposition the camera. We'll take a closer look at this old piece of test gear here, and then we'll open it up and I'll show you exactly how this thing works, and we'll talk about the parts inside and talk about the future restoration. Here's a closer view of the face of the Simpson Genescope. And really, the design intention of this piece of test gear is for FM radio and television alignment. And I think what Simpson was thinking when they put this thing together is, let's take a whole bunch of pieces of test gear, put it into one case, make a really impressive looking piece of gear, and that allows the serviceman to maximize on his bench space. Now, if you were a television and radio repairman way back in the day and you had this thing displayed, your customers would walk in and go, wow. And I think there's a little bit of that in there as well. So it works on a whole bunch of different levels. Now, they call this thing a Genescope, hence signal generator and oscilloscope. Now, this is a whole bunch of things in one. We have an AM signal generator on this side, we have an oscilloscope in the center, and we have an FM signal generator on this side. And these are all linked to this oscilloscope through a bunch of switches so that you can do sweeping and do a whole bunch of different functions with this thing. So it really is a versatile piece of gear. If you wanted to use the oscilloscope for something else, you could remove this little door and you have direct access to the vertical and horizontal deflection plates in this little CRT here, so you could use it for other functions as well. So really a very, very versatile piece of equipment for the bench. And it really is quite impressive. This thing looks like a black mirror. I can see everything inside it. It is so shiny, and it's so difficult to actually have the camera make this thing look good, because everything that you see in here isn't dirt or scuffs or anything. It's actually just all reflections from everything around here. And in the picture, the same thing. The original picture that is in the beginning of the video, that's just all reflections. There is a little bit of a crease down here. It looks like it got damaged down here. But other than that, the thing is really in outstanding condition. So in the end, when I end up doing the complete restoration on this thing, I'll have to get some pretty interesting camera angles to make this thing look pretty good, because it really is pretty shiny, and if I clean it up, it's only going to get better than this. I haven't touched this thing. It's basically come here, it sat on the floor and for a very long time in the other room, and I figure, oh hey, this would be kind of a neat little project to get into here in the near future. So let's take a look at this thing. Now, there's one thing I think that Simpson should have done to this thing that they would have probably really, really cleaned up with this device. This is the problem. They classify it as an FM and TV alignment tool, but way back in the day when this thing was put out, AM broadcast and shortwave listening was a very, very popular thing still. Now, the bottom end of the signal generator here bottoms out at about 3.3 megahertz or so. Why not give it one extra range and have it go right below the AM broadcast band, so that you can have through the broadcast band, through the 160 meter band, right up to the bottom end of the 80 meter band here. And then you could have called this thing an AM, shortwave, FM, and TV alignment tool. Why wouldn't they have done that? It really is just one more selection on the switch and maybe another coil here. And they would have probably really cleaned up. So maybe Simpson had another line of equipment and they didn't want to, have everything all in one. They probably wanted to sell you a different piece of equipment. I really don't know their thought behind that, but I think that it would have been a much more versatile piece of equipment if they would have done that. Now, that I do a lot of antique radio restorations and things like that, and if I'm doing any kind of a television repair, of course this thing is going to come in very handy, but it's just going to sit off to the side most of the time. So if I do modify this thing a little bit and make this go down through the AM broadcast band, I can use this thing a lot more on the service bench, and you can see this thing in use quite a bit more. Then that'll be on that antique service bench that I'm putting together. So let me know what you think about that. Do you think I should add that extra range in here so that we can use this thing a little bit more often? Or do you think I should just basically leave the thing stock? Let me know your thoughts down below in the comments. I'll also have to change these jacks here. These are very odd jacks. This looks like the same kind of jack but inverted, and these are the oscilloscope input jacks. This is a vertical input jack here and a horizontal input jack, and this is the signal generator output jack. So what I'll do is I'll just replace those with BNCs, and it really is a straight sub. You just take this thing out and put a BNC jack in there, and you can't even really tell anything has been changed unless you really know that these jacks were here originally. It's a nice clean install. So again, let me know what you think. Let me know if you think that I should do that, or just completely let this thing remain stock and use it for just television alignments. So what we're going to do now is I'm going to remove the screws out of the face. You can see that there's just a few screws in the face here. Here and here. It looks like all the rest of them are missing. There's screws everywhere here. So we'll take a look inside. I really don't know what's inside this thing. It's just been sitting here, and what you know is what I know. I went on the internet and I downloaded a schematic. So we'll take a look at the schematic of how this thing is all put together. And there's also, it's kind of a service manual / owner's manual thing that they had online. So that, I've kind of just briefly glanced through it to get an idea of what we're going to be up against here. And I can tell you already, this thing has a bunch of surprises inside it that will absolutely surprise you. It did to me when I looked at the schematic. I'm like, wow, that's extremely impressive for its day and age. I'll give you a little hint. I won't go much further than this until we run across it in the backside of the unit here. They claim that these dials are accurate to within 1%, and they stay accurate. So there's a little bit of a hint. So they've done some pretty neat stuff inside this device way back when to keep this thing very, very accurate. So again, when I open this stuff up, it's kind of like reading a book. We can open this up, look inside, we can go through it piece by piece and see what the engineers were thinking way back in the day when they put this thing together. And it's kind of a bonus when other people get in here and tamper with it, because we also get to see what the technicians throughout time were thinking when they were repairing this. Again, it kind of plays out like a story, so it's interesting stuff. This is how the Genescope operates according to the schematic. And how I'll explain this is I'll first go over this really quickly. I'll just give you an idea of how everything's all hooked together in here and what everything does. And then I'll come back and explain each section in detail. So I'll start here with the AM signal generator section. What they've done is they've marked this one AM signal generator off with a dotted line, and they've also marked the FM signal generator off with a dotted line. And these dotted lines are actually representing the boxes inside the Genescope itself. So this is the sealed AM signal generator, and this is the sealed FM signal generator. Kind of works nice on the schematic too, because it does create separation between the two parts. So AM signal generator, FM signal generator here. We have our attenuation section right here. So basically these are the signal attenuators for both the AM and FM signal generators. Up here we have the power supplies. We have 2 power transformers in this unit with 3 rectifier tubes. Right here is the entire oscilloscope section. So this is the CRT. This is a horizontal and vertical amplifier section right here for this oscilloscope. And this is the sweep section for that oscilloscope right here. Up here we have some filtering on the line cord. This is a very interesting little thing. So this stops this signal generator from letting signals back out the line cord and into our wall, so we don't use the wiring in our walls to transmit with. Now what's another very interesting thing is they show the line cord itself being shielded. That's a really neat little thing to have. So they're actually shielding the line cord right out of the signal generator right up to your wall outlet. Kind of a neat little feature here. And that really is quickly an overview of how this thing is just put together and all the little separate sections here. So next what I'll do is I'll start off with this AM signal generator circuit, and I'll work my way around the schematic and explain in detail how this whole thing works. This little upper box that you see here represents the AM signal generator section inside this Genescope, and this is how it works. So this 6C4 tube here is acting as a variable frequency oscillator. So this tube in this oscillator section is getting moved around when you move that knob on the AM signal generator portion of the Genescope. So when you see that little needle moving on the AM generator section, it's shifting this oscillator section around. These dotted lines here indicate that these capacitors are ganged together. That means that there's 2 capacitors controlled by one common shaft. So there'd be 2 capacitors moving with the movement of one shaft. Same thing goes for these wafer switches as well. Whenever you see dotted lines joining these wafer switches together, that means that one common shaft is moving 4 separate switches here. You can see that there's arrows inside the switch that indicates the rotation of these switches. You can see 1 front, 1 rear, 2 front, and 2 rear. They've done a really nice job of marking these particular wafer switches. A lot of schematics, they don't do that. And you actually have to compare what's inside the unit to the schematic to figure out the rotation and the certain portions of the switch. So it's really nice that they did this in this schematic. This 6J6 tube here is actually 2 triodes in one glass case with one common cathode. So the cathode is joined together. So we have 2 separate plates, 2 separate grids, and one common cathode joining the 2 together, making this 6J6 tube excellent for a mixer service. And consequently, it makes a really nice phase inverter circuit for audio circuits as well. But we'll talk about that in another video. So this tube is very busy in this circuit. It's doing a lot of things. This crystal here is our frequency standard for the AM generator portion of this circuit here. So this is that fixed frequency standard giving us that excellent stability in this one section. This crystal is using this portion of the 6J6 tube as an oscillator and a mixer at the same time. This 6C4 variable frequency oscillator that we just talked about, the signal from this tube is getting picked off the grid and fed through a 10 picofarad capacitor into the grid of this side of the 6J6, which is another mixing tube. So as well as mixing this signal from the VFO, it's also mixing this signal from this audio oscillator here. This is a fixed audio oscillator circuit, and this generates a 400 cycle tone. That 400 cycle tone is available at the plate of this 6J6 tube here. So this one 6J6 is doing a lot of stuff. It's acting as an oscillator and a mixer on this side. On this side, it's acting as a mixer, mixing this variable frequency oscillator signal in with this fixed audio signal, and all of that is mixed and available at the cathode here. So the signal comes out the cathode through this 47 ohm resistor, down this line, through this 2000 picofarad capacitor, and down this shielded piece of coax. You can see the shielded coax here. That dotted line on the outside of the coax indicates the shielding, and you can see it's tied to ground. And the center is shielded, and that runs right down into this attenuation network, and it's available at the output jack here on the face of this Genescope. And that's, in short, how this little AM signal generator section works. This is how the FM signal generator works in this schematic here, and that's indicated by this box here on the bottom, this dotted line box. So much like the AM signal generator, we have another fixed oscillator right here, which is a 6C4. The only difference is this one is not crystal controlled like the AM signal generator circuit. So we have a fixed oscillator right here. And on the top we have our variable frequency oscillator, and this oscillator is moved around by that knob on the face. Whenever you move that dial around on the FM signal generator, it's shifting this oscillator circuit. And we also have the provisions to sweep this circuit with a motorized sweeper right here. So basically what's happening is this motor is spinning a capacitor around in there, and that's creating a sweeping effect. And that's all controlled by this FM sweep control here, and that would be the knob on the face of this Genescope. So the signal, the FM signal, is available at this point here. This is the actual signal path. It's coming out here going through this 3.3 picofarad capacitor and into the control grid of this 6AK5 tube, which is acting as a mixer. This fixed oscillator signal is also coming up through a 3.3 picofarad capacitor into this line, and again it's getting mixed at this tube. We have the signal available at the plate, and that runs out this shielded piece of coax and down into the FM attenuator network. Here we have a blanking feature which allows us to do our blanking. So now this is a 6C4 tube, and it's controlled by an AC winding on a transformer here, and this is our little phasing and control network here. And you can see these lines, they run directly right up to a winding. So basically what's happening is a tube will work when we have a positive voltage on the grid. So basically the tube is going to turn on at that point. It's going to conduct when the grid goes positive. So we have a 60 cycle AC signal available at this point here. So on the positive half of the cycle, we have this going positive. As this is going positive, the 6C4 is turning on. And when this turns on, this is pulling the voltage down at the plate, because technically you could look at this as this is trying to connect the plate to ground when this is turning on, right? It's trying to connect the plate to the cathode here. So on the positive half of the cycle, this tube is turning on, dragging the voltage down at the plate here. You can see we have plate voltage going through a 100K resistor and right to this point here. So as this comes to zero, this tube is starting to shut off again, and as it hits zero and goes negative, the tube goes completely off and the voltage rises at this point again because there's nothing pulling it down now. The tube isn't on anymore. So as it comes around and it hits the line again and it starts to go positive, the tube starts to conduct and pull this line down. So in effect, we get pulses at this point. We have a 0.25 microfarad capacitor here, and that's in line with this. That's running up to this 56K ohm resistor. We have a blanking switch here, which enables this entire function. That's also ganged to a potentiometer on this side here. Those blanking pulses are running up this line here and into this oscillator circuit here, and that is what's providing our blanking. We're now on to the power supply portion of the schematic here, and as you can see, we have 2 power transformers and 3 rectifier tubes. So this rectifier tube here is supplying the voltage for the 3kp1 CRT, and as you can see, this is in a negative configuration here. This larger rectifier tube is supplying the bulk of the B+ for the AM and FM signal generators here. So you can see we have a completely separate power transformer, and that's how they're getting a little bit better regulation. So things are a little bit more stable by doing that. So you can see we have the L9, which is acting as a filter choke, and we have a path up this way here into the AM signal generator portion. And if we go this bottom route here, you can see we have a path which is labeled 350 volts here into the FM signal generator portion. So that's basically what this one tube is doing. The 6X4 here does power some other things. It runs over here and powers the plates of these 6J6 tubes, which are the horizontal and the vertical amplifiers for the oscilloscope over here. So nicely separated power supplies, and by doing that they're getting, you know, a little bit better regulation and things are a little bit more stable. So, you know, with AC line dips we're not going to see too much of a difference in frequency, because AM and FM signal generators are very, very sensitive to any kind of line voltage movement. And you'll notice that this schematic has absolutely no glow discharge tubes as regulators. So no OA2s or OB2s or, you know, OD3s or anything like that in here. So there really is no regulation. Nothing that's, you know, very tight anyways. Over here we have the oscilloscope section. So we have a 3kp1 CRT, and we have a horizontal and vertical section here. And over here we have a sweep section, which is creating the sweep frequency, the horizontal sweep frequency for the oscilloscope. So you can see here we have our vertical signal path. So if we follow the vertical input here, runs up into this switch here, goes up this shielded line into this switch, through this, back out this shielded line, back through this half of the switch, down here, and right into this vertical sensitivity control. So this is our vertical line here, through our vertical gain control, and into this first 6J6 tube, which is acting as an amplifier. Goes through this and into this second stage here. We have our vertical centering here. And after this stage, it goes from this up here into the, what looks to be, horizontal deflection plates. That's very strange. Our vertical signal's coming up here, and yep, they've got it drawn into the horizontal deflection plates. That's very strange. What I'm going to do is I'm going to go get the tube legend for this here and see what they've got written down, what they're doing here. I have a copy of the tube legend here, so let's see what they've done in this Genescope. So we can clearly see that this is the vertical path. Alright, we have a vertical sensitivity here. Our signal will come up through this potentiometer here, go into this grid of V14, which is a 6J6. This is our first vertical amplifier. And then we have our vertical centering control here, and this is our second vertical amplifier. So we see V14 and V15 over here, V14 and 15 labeled as the first horizontal amplifier and the second horizontal amplifier. Now, what will make this very confusing to somebody that doesn't understand the topology of this circuit is that these are actually running off to the horizontal deflection plates. So the tubes are labeled wrong, and they also have them tied to the wrong plates in the 3kp1. So if we look at V12 and V13 here, V12 is the first vertical amplifier, so they've labeled it. And then we have V13, the second vertical amplifier, as they've labeled it. All right, yet we can clearly see we have our horizontal sweep range selector here. The signal runs out this path through this capacitor down into this switch. It follows this line here, through this potentiometer, and then back up into the grid, making this the horizontal section, yet they've tied these to the vertical plates, and they're labeling these as vertical amplifiers. So this would get very, very confusing to somebody that wouldn't understand the topology of this particular circuit here. So to make this simple, V15 and V14 you would relabel here. All right, you see V15 and V14, they've labeled these as horizontal amplifiers. You'd scratch out horizontal and write vertical in there. And V12 and V13, you would scratch out vertical and write horizontal in there. Then in order to make the schematic correct, what you would do is disconnect all four of these leads and you would just reverse them. So D1 and D2 would attach over here, and D3 and D4 would attach over here, and that would make this correct at that point. So anyways, I guess somebody was asleep when they were doing this. It happens quite often. You know, this is back in the day, this was a pretty complicated schematic, and I guess somebody was, this probably got overlooked. Probably too many people working on this one schematic, and, you know, again, this just got overlooked. So this here is the horizontal sweep oscillator here, 6J6, V11, we can look here, V11, linear sweep and blanking. So it's using all these different capacitor values here to create the different, the sweep ranges in conjunction with this oscillator here. And we also have a sync control over here. These here are just our attenuators. So the reason that we have attenuators is so that we can basically turn the signal from the signal generator down at the output jack here, so we don't overload the certain portions of the circuit in the television or the FM receiver that we're working on. So just attenuator circuits is all these are over here. And all these sections are somewhat connected together to the oscilloscope through all of these different switches here, so that we can display a sweep on the scope here. And again, that sweep is provided by M1 over here in the FM section. So a very versatile device, and it's a pretty neat design. Again, this kind of stuff is not a big deal. I know a lot of people, when they see this kind of stuff, they lose faith in a device like this. And you know what? I come across this all the time, and in this old gear, people are drawing things the wrong way. Again, not a big deal. Just make those slight revisions, and the rest of the schematic looks pretty good. So here it is with the thing laying on its face, kind of open, and I have to have a wide-angle lens on this thing to get everything in the shot, and I still can't get everything in. There still is some circuitry under these two covers here that we'll take a look at first. So this is really what this thing looks like inside. It's pretty busy in here. So we have two power transformers in here. We have a choke over here. We can see the tubes that we have here. So this is all the rectifier tubes, and we have a filter capacitor here. This is the CRT. And we have one tube under here. Underneath this little platform here, there are 4 tubes down like this. And that's about all I can really see for the tubes at this point here. So what I'm going to do is I'm going to flip this thing up, and I'm going to remove both of these covers so that we can see in both of these little RF oscillator areas here. And what I'm going to do is probably have the camera just handheld so that I can kind of focus in on the little areas, because this really is such a big area, and we have to look in lots of little crevices and cracks here in order to see everything that's going on. Here's the back side of the Genescope with the 2 covers removed off both of the signal generators. This side here is the FM signal generator, and this is the AM signal generator on this side. And let me tell you, looking at the FM side, this doesn't look all that friendly to service. They've got a sub-chassis kind of halfway up the box here with a whole bunch of tubes mounted to it, and it's completely shielded. Everything is facing towards the face of the unit. So in order to get at the components on the back side here, I'm going to probably have to remove this entire box to get in there. And I can't see a sweep motor anywhere, so it's either hiding in this box or behind this chassis here, and that will all have to be looked at. So there are 3 tubes mounted to this sub-chassis, so there's obviously capacitors and resistors back there that probably need to get changed. In the box, there's 1, 2, 3, 4 vacuum tubes. We have another filter can just like this one right back here, and we'll take a closer look at that in just a moment. They're tuning the FM section here with a variable inductor, so they've got a curved horseshoe, and on this box they've got a bunch of fingers that ride each side of this horseshoe here. So as you turn the knob on the face of the unit to adjust the FM side, this unit moves around. So as we get these fingers here closer to this end, because we have the horseshoe here, the frequency is going to be high at this end, and because as we move this away here, we're getting further away from this end, so the length is longer, the frequency is going to go low. So this would be the low end of the inductor, and this would be the high end of the inductor here. You can see we have the little tube underneath here with very short lead length going into this box here. Because we're dealing with VHF frequencies, any kind of lead length whatsoever is inductance. So we got to keep everything extremely short, especially at the VHF frequencies. Looks like they've got some sort of a neat looking little gimmick capacitor in here as well. We'll take a closer look at that in a moment. Lots of roundy style resistors in here, not their later Allen Bradley style. So chances are those have moved in value quite a bit. So this looks like it's going to be quite an in-depth restoration, let me tell you that. So lots of pink Sangamo capacitors in here. And I can't remember coming across pink Sangamo style capacitors. I know the Tiny Chief capacitors are pink, but these ones are pink Sangamo, so I'm not sure if these are going to be paper. I imagine they probably are. So what we'll do here is I'll find one that's kind of easy to get at. I'll open one end and we'll check it for leakage here. I know that the pink Sangamos are factory in here because there's some hiding way in the back side of this box, and it looks like it hasn't been touched. So somebody's been in here and done a real crappy job at servicing this thing. They've replaced some resistors down here. The reason that these resistors have burnt probably is because there's leaky caps everywhere. Look, they've left this old electrolytic in here, and they've changed a few caps out. There's a yellow, newer style capacitor in here, you know, but it's still looking pretty ugly. Look at this bumblebee style capacitor. It looks like it's sweating. It is. It's actually sweating. So this is yellow, purple, orange. So that's 473. So that's 0.047 microfarad. So that'll definitely have to get changed. Looks like there's a big solder blob on the end of this side of it here. Definitely leaky, and that'll need to go. Leaky in both sense, you know, physically and electrically, I'm sure. So inside the AM signal generator box here, this looks quite a bit easier to service. It's pretty wide open here. There are some components on the back side here, but at any rate, doesn't look as incredibly bad as this side here. We have two variable capacitors, trimmer capacitors, and two inductors, and these are obviously to align the dial scale to the frequency that this thing is putting out. Looks like this is our frequency standard. It says 5,000 kcs, so in short, that's a 5 megahertz crystal. We have a 6C4 here, 6J6, and then there's that other 6C4 in the front there, probably the oscillator modulator tube for this transformer up here, so we can get our 400 cycle tone. That's what I'm imagining. Looks like they're using roundies in here, but these roundies have got gold bands on them. They're 5% tolerant, so maybe these will be okay. We'll have to go through and check all of these out in the end. The oscilloscope itself looks like it's, you know, pretty rough to get at the components in here too. There's lots of components tucked way in behind here, so I'll probably have to remove the CRT and this shield and maybe get in this way. And you know, worst case scenario, I might have to remove this entire thing from the unit itself. So lots of tight components, you know, really crammed in this unit. So lots of stuff to do. So what I'll do is I'll remove the camera from the tripod here, and we'll take a closer look inside these boxes. All right, here's a close-up of that variable inductor inside this FM signal generator. You can see the little fingers there that rub that inductor there. And if I can move this, you can see how that inductor moves around. So it'd be going up in frequency right now, and this would be going down in frequency. You can see the short components down there on the bottom side of the box. Again, lead inductance is a big issue. In the bottom here, you can see the sub-chassis. You can see on the side of the box, it's kind of halfway up, so need to get behind there. And there's another filter capacitor there. Some sort of a trimmer capacitor right here as well. Again, that sweep motor might be behind here. I'm not really sure at this point, or it might be hiding in this box. I don't know what they're doing in here. On the bottom half here, we have a filter choke here. Another one of these pink Sangamo capacitors, and a power transformer, a whole bunch of dust, and some variable resistors there. This is the power tranny here. Lots of taps on that transformer. In the center, we have the oscilloscope here, and on the bottom we have a bunch of resistors that have been replaced. This one cap needs to go. Looks like it's kind of been tacked in there. Somebody's opened up one end. It's probably at some time they tested it to see if it was okay. Here's our sweaty Black Beauty capacitor. Bunch of resistors tied together. These look like very old style resistors in here, so somebody's probably way back when serviced this thing with these really old resistors. And we have a bunch of inductors in here, some mica capacitors and some roundies over the top. You can see that new yellow capacitor that they've replaced there. Another one of those Sangamo caps. One here. And on this side you can see a whole bunch of components kind of hiding around the corner in there. So that looks like a lot of fun to service. I think it's a 6J6. Yeah, it definitely looks like one. So in the AM signal generator box here, you can see that transformer in the back side there. We get a little bit better light going on in here. See that transformer in the back, and you can see our crystal here, our standard. We have a bunch of tubes here, 6C4, looks like a 6J6 and another 6C4 in the back. And, you know, the inductors and capacitors, some associated components on the back side. So again, this looks quite a bit easier to service. They've got the tube sockets mounted to some form of a, it's definitely not metal. Almost looks like it's some form of a bakelite or something plastic compound here. It hasn't warped over the years, so some sort of a fibrous material that's holding the tube sockets. So they've probably done that so that they can kind of do a star grounding system or something like that. Most likely to stop parasitic oscillations and things like that. You can see all the feed throughs on the bottom. So lots of nice feed throughs, keeping the boxes very nicely shielded. So when they put this thing together, they did a really nice job. You know, it's top notch what they've done here. Lots of thought went into this thing. Definitely not like the way a piece of Tektronix gear is put together in the early days, but still, you know, very, very respectable job they did putting this whole unit together. Okay, so here we are looking at the bottom side. Again, we can see the power transformer and the filter choke. Looks like they have some shielding going on in a box here. Same thing on this side over here, most likely the attenuator or something like that. So you have a mixture of old and new resistors here. So definitely it has been serviced throughout time. On this side here we can see that you have a little board that mounts a few components over here. Variable resistor right here amongst all the dust and dirt. Here's the bottom of the CRT, and we can see our 4 tubes. So we have the vertical and horizontal amplifiers down here, and somebody's replaced these caps. Look at that. What are people thinking? I don't know why people do this kind of stuff. You know, do the job right or don't do it at all. That is hokey. And these capacitors are so soft. You know, these things are like marshmallows, these capacitors. You know, you just even touch your soldering iron to these things and they melt, and these things are tight up against the tube like that. So, you know, I don't know. These are all going. Just garbage. So you can see we got resistors down here and a fuse in there. This is our other power transformer here. This is our filtering here. So this is our filtering on our line. We can see we have these normal Sangamo capacitors here. Really aren't safety rated style capacitors. So these will have to get changed out as well. These are the 2 filters here in line. You see those filters there, and this is our line cord. Kind of falling apart here, and the line cord is shielded. As we can see, it's got a shield going right to the chassis. So this is the original line cord that's with it. We have a bunch of lamps down here, probably 47s or something like that. That's really the bottom side here. Looks like the fuse is probably appropriate. A very thin wire in there, so it's probably the stock fuse. Look at this thing, how leaky that capacitor is. You see how this looks like it's soaking wet. Typical Black Beauty capacitor. Bad news, these things. So there it is. Here's all the connections that are below that little kind of panel on the front, so that you can tie right into the horizontal and vertical deflection plates there. Pretty busy device inside. Lots of stuff to repair. So this would be like working on a in-depth, I guess, communications receiver. That would be about the level of complexity in restoring this thing. Getting into that second layer inside this FM box, you can see it's completely shielded on the bottom here. It's that kind of a sub-chassis midway up the box. So you can see that this is going to be quite a job to get this off here. And if I have to remove this whole thing, look at everything that has to come off, and this whole thing will have to come right off. So that doesn't look too incredibly easy to replace. So usually when I go onto something like this, you know, in the top here, when I go and get behind this little sub-chassis here, I'll replace almost all the components in that box. So that way there's nothing to go wrong in the future. Put overrated components in there, so basically you never have to go in there again. That's how I look at things. It's the same thing like, as I mentioned earlier, the Hallicrafters SX28A. This really reminds me of that. So the Hallicrafters SX28A, you put really overrated components in all of those boxes and make sure everything is, you know, good for the long run, so you never have to go in there again. Little story about the SX28A. When I was working on one of them, somebody underneath the box, I think it was written at the factory at Hallicrafters, somebody wrote under the box when I removed the box from the chassis, it says, "What are you doing here?" I don't know if, I think I have a picture of that in my computer one day when I'm working on an SX28A. I'll include that there. So it looked like it was from the factory, because it didn't look like anybody else had ever been under those boxes. And once you work on one, you'll understand why. So there it is. That's the inside and a preview of how this thing is put together and how we're going to be servicing this thing in the future. So what we'll do is we'll open one of these Sangamo capacitors here. I'll find one that's kind of convenient, open one, and let's see if they're leaky or not. I've removed the two filter capacitors from the line cord section here. So these tie from the line cord directly to the chassis of the device. So if these things are leaky, poses quite a shock hazard to the chassis. So I figured that these would be the most exciting ones to check out. So let's see how leaky they are, if they even are. Who knows, they might not be. So what I'll do is I'll take the negative and clip it to the chassis here, and that's going to my Jackson Model 591. Hey, old Jackson test gear needs love too, right? So let's use this old Jackson, works very well. So what I'll do is I'll clip this here onto this end. So we have a path here, capacitor, and the negative is tied to the chassis here. So I only need to open one end doing it like this. So we want to go down to the bottom here. It says paper, and then we have electrolytic here. So this is the one that I want to push. Right now we're going to put 6 volts across this capacitor, and if that eye opens, it's okay at 6 volts. So let's try it out. And it is. But you can see how it kind of slowly opened at the end there. All right, when you let the switch go, it discharges the capacitor as well, so it doesn't leave the cap charged. If it's a good cap and you're putting 500 volts across it and it doesn't discharge it, you're in for a surprise when you touch that capacitor again. So it's kind of nice that they did that in this particular capacitor tester. So here we go. Now watch, you'll see it kind of slowly open as it gets to the end. See that? It's 6 volts and it looks like it's already trying to leak. Let's go to 20. See what happens at 20. Look at how slow that's opening. This thing's leaking with 20 volts across it, and the capacitor's rated 0.05 at 400 volts. So let's go to 100 volts. Here we go. It's not even fully opening, so we have some pretty good leakage going on even at 100 volts. Let's go to 200. The eye's not even opening anymore. So that's how leaky this capacitor is. So these pink Sangamo capacitors are leakers. Definitely paper hiding inside this thing. Let's go over to this one and test this one out. So I'll move this over here. All right, just get this one out of the way. Leave that there. Okay, start at 6 again. Pretty much the same kind of idea. Go to 20 volts. And it's opening again. We'll go to 100. I don't think this one is leaking as bad, but it is leaking. Let's go to 200. And it's opening at 200. But it is leaking. You can see the eye isn't fully opening. Let's go to 300. It's trying. And as you can see, it's excessive leakage. This capacitor is definitely faulty. So compared to a new capacitor, this thing would just open right up. So we can tell that those capacitors are leaky. So having old capacitors like this tying from the line cord to the chassis presents an extreme shock hazard in a device like this. So if this thing had a 3-wire cord on it, I imagine it would definitely be tripping if you had a GFI breaker, it would definitely be tripping that. But at any rate, so these definitely have to go. So whenever you find any of these old style capacitors tied to the line cord, you want to definitely get rid of them, because these things are just nothing but trouble. And you definitely don't want to take any chance here. Let's move the camera over a little bit. So these here are most likely mica capacitors, and I'll end up testing these things as well. These are 0.0082 microfarad. So in the end, when I go about doing the restoration, I'll probably end up checking these. Now, these aren't a safety rated capacitor, so chances are I'll probably end up removing those things as well, because I don't want, any ties from the line cord at all to the chassis. Now, this is shielded. This line cord actually has a shield on it. And at the end, it runs right out the end. So I'm not sure whether they intended this to have a 2-wire plug in that shield just ran right up to the end of the plug, or whether that shield actually went to the third wire. But it looks like it could very safely be used as that. But the problem is with this cord, it's going to probably have to go anyways because the cord itself is cracking here. So I'll probably have to get rid of this line cord. So unfortunately, yeah, I guess this shielded cable is probably done. Again, when it comes time to do the full restoration, we'll address this at that time. So pink Sangamos, horribly leaky. Okay, just for the fun of it, let's test this horribly sweaty bumblebee capacitor. Look at this thing, it's so nervous it's sweating. Yuck. All right, here we go. Take the negative lead, put it on this end. Take the positive lead of the tester, put it on this end. And let's see what we get from the famous bumblebee capacitor. Okay, so let's go over here. I don't know if I can get all of this into the shot. Let's see if I can. Just barely. Might look a little bit hazy if I do that. Alright, so we'll just focus on the tester here. Alright, let's start at 6 volts. Here we go. Opens up at 6 volts. Not bad. 20 volts. Oh, it's slowing down. Oh, it's actually coming together. That's pretty bad. Let's go to 100. There we go, 100 volts. And it's coming together. It's not actually going apart. So as we're testing it, it's getting worse. Yeah, that's pretty bad. So this bumblebee cap is definitely toast. Look at that. It comes together as we test it. As we apply voltage, it gets worse. That's why it's sweating so bad. It says, "My days are done." So there it is. The famous bumblebee capacitor. Toast, definitely. And very sticky. Thanks for stopping by the lab today. I hope you enjoyed the first video in this series, this one involving this Simpson Genescope here. If you did, you can let me know by giving me a big thumbs up, and don't forget to leave a comment down below. Again, I do read every single comment and I do take them very seriously, so let me know what you think of this new series. So until next time, take care. Bye for now.